between those different languages. I even did it with a basic a little bit.
Oh, I like the basic. I think the basic is my favorite of the three languages.
Yeah, it's actually does floating point. No, I mean, it's cool.
Hey guys, we ready to get started here?
Yeah.
Okay, I'm just gonna mute you, but you can unmute yourself anytime you want.
All right.
So just hitting recording, doing a little bit of housekeeping here. And the mute all button doesn't work, so yeah, no kidding. If you want to mute yourself, go ahead. If you don't. Yeah, I found the reason why it wasn't working. Okay, so feel free to unmute yourself. Welcome to the Propeller 2 live forum and open discussion. Everybody, sorry we missed last week. It was an important break so we could get some things done. We got some good topics today. We will talk about a couple things that came up from various contributors were just how to use GitHub, or more specifically how to get Parallax P2 files off of our GitHub page. So Jeff's going to talk about that when he joins. We're going to discuss the progress we're making on some of the click objects, and maybe JonnyMac will show his real-time clock. And we will also show the progress on the P2 Edge breakout board, which is super exciting, and where we're going with just a couple minor business things with distribution. And Chip wants to share some things relative to debug and graphical tools, and then Q&A. And somebody out there asked about generating a sine wave with the P2. So just before we get going, really quick, while a few more people roll in here, I got a story I'll share. It was my weekend, and whenever I bring this kind of stuff up, everybody goes silent, but this is really about robotics. And it's an interesting story that robotics made possible. So you may have seen this even on national news. It's about a man that was recovered from the bottom of Lake Tahoe in 1,565 feet deep on Sunday. Anyone see this yet? No, okay. So what is this about? Just super briefly, this gentleman here was unemployed due to COVID from New Jersey. His name is Ryan Normoyle. Came out to California, rented a boat, and went out to the very middle of Lake Tahoe, which is 12 by 29 miles. And he's grabbed his video camera and he put it on the back of the boat, actually his phone, and then he filmed himself doing a cannonball off the back of the boat. What he didn't know is the boat was in drive, and he was not wearing a life jacket, which who knows if that would have helped, but the boat drove away and it left behind the GPS waypoints of his phone. So there's a group out there that came here. Their name is Bruce's Legacy, and they're actually from Black River Falls, Wisconsin. I know them from a prior work we've done together. So they came out here. They've recovered 32 drowning victims with their robot. And on Friday morning, we went out on this boat, which is a very expensive South Lake Tahoe Police Department boat. And we began the search based on the GPS waypoints using this ROV. So this is an ROV that can go down to a couple thousand feet, and it's got on it a sonar. That's the blue thing on the front. And then these are LEDs on the left and right. They're those super bright MikroE LEDs. And there's a camera in the middle that can pan up and down. It's got up and down thrusters, side thrusters, and it has a 2 degree of freedom claw out here. So it can open and then turn. So it's very limited. So we put this thing, we drove actually out to the location. We put this in the water, dropped down, everything on it failed, like happens on robots, especially at a very deep elevation. It was like 650 PSI. So anything that's prone to failure will start failing. And the motors didn't work on it, and the nothing worked. The sonar was down and the camera was down. The camera was up, flickering. Somehow we dragged this right to the right spot based on the GPS coordinates. But we couldn't really do anything because our claw didn't work. So we got another robot and brought it together, and we started taking parts off of one. And then like the claw was working on one and the sonar worked, not another. So these are $100,000+ ROVs. And here we are moving the claw and then replacing with another part. And the control system looks like this. So you've got this massive power supply box, and then this signal management box, a computer which shows the sonar out to 250 feet when you're on the bottom, and then the camera display. Then there's a little control panel you see on the bottom here, so you could drive the thing around. So about 20 hours into this, we got a working system going, and we dropped it down. And on the third day, we actually succeeded and located the victim. And this is me right here. My job is to communicate with the guy who's driving the robot, and then fix the robot and just manage whatever technical things I can on the deck. And so here we are, just raising the robot up. It takes about 2 hours, and day kind of wrapped up looking like this. But it was an absolute amazing thing, and it was the deepest recovery in North America, actually, of a drowning victim. And I think maybe even in the world, I'm not sure, aside from, I know some Army recoveries were made with divers once, but we were able to bring up the deceased and return him to his family. It was super impressive. And what's interesting too is we're very involved in educational robotics, as everyone here knows. It's a big part of our business, something that we believe in, that brings us a ton of fulfillment. And we hear all the time from teachers about what their students have done after they've programmed microcontrollers and robots and the kinds of technical jobs they go on to. So the guy we're working with is this gentleman. His name is Keith Cormacan, and his organization is Bruce's Legacy. They recovered 32 bodies so far of drowning victims. And his shop, which outfits the ROVs and sells them and does trainings on them around the world, has a student in it that also learned on Parallax's robots, which I thought was really cool. So we see these connections getting made, and they're super thrilling. So anyway, I put in 40 hours between Friday morning and Sunday evening, and we did something meaningful and with the robot, which is great. And I'm collecting up some donations to send to them. If you guys are so inclined, go ahead and drop a few dollars of coffee money. That's somebody other than Roy Eltham this time, to eBay sales at parallax.com. We'll match it and send it over to Bruce's Legacy so they can continue doing their work.
You can't stop me.
Roy, #1 helper. You don't have to. So it's eBay sales at parallax.com. No pressure, but we'll match it and then give this guy some money to get some new tires for his boat trailer. So it's pretty interesting, isn't it? Yeah, it's really good use of robotics, people helping other people, and you know, while you can't bring home the living, you can definitely give them some closure, which happens more often than we know. So moving on.
In chat.
What's that? Oh, thank you.
The link in chat.
Okay, cool. P2 Edge is officially sent off to production. And wow, just watching the discussion go back and forth between Michael and the PC board fabricator was interesting. It was new points brought up and new issues about everything from drill sizes to number of layers to copper to just really optimizing this. And I think these guys really got it right. So Chip and Michael worked day in, day out for a long time on this one. Chip, do you have any comments on that? How it turned out? You'd have to unmute yourself.
Yeah, well, I don't know. We went around and around, and we tried to just put the essentials on. You can see on the left side of the board, there's a 1.8 volt switcher that takes 5 volts that comes in on the board and converts it down to, you know, high current 1.8. And then like on the P2 eval board, we have a bunch of small LDOs that feed 8 pins each. And then over on the right, there's the, that's the flash, right? And then some resistors that it needs. And then above that, you see that little tiny 6-pin chip? That's just a little buffer to drive these 2 LEDs so that we don't load any IO pins unnecessarily. So the buffer is always on and always connected to the to power, or it's connected to the IO pins. But in case you don't want these LEDs going wild, you can flip this first switch off, the one that says L, and it'll just disconnect like the common cathode from the LED, so they won't light up anymore. But it doesn't, you know, power down the buffer because we don't want to, you know, load up the P56 and P57. Then we just have the flash enable and then the P59 pull up and pull down. And it's designed that if you plug it into where a microbit is supposed to go, it's not going to hurt anything. And if you can power the backside with 5 volts, then you could actually drive microbit stuff with it.
And let's see, Chip, so the connector, there are two formats. There's a straight up one and a right angle, and we're getting them both in stock at just sort of 1,000 of each. And we'll sell them to our customers as cheap as we possibly can, probably like $1.35 each. All right.
You said right angle, that would only be on the board that it plugs into, right?
Yeah, so we have the right angle already in stock because we make a breakout for the microbit.
Oh, okay, right.
Yeah, so this will use the vertical one. I think they're the same footprint, but anyway, so we'll have both. So people that want to use this in products will have that connector.
Oh yeah, and one other thing on the back side of the board, Ken, is this a slightly older one? Did you
It is, yeah.
Okay, because now these 6 pins, the circles you see up, down, or what is that? RX, TX, reset N, ground, and then the ground and 5 volts. They're all in a line right now. So there's 6 in a row, but you can solder a little, and we also made those pads longer so that we can put a right angle 6-pin SIP header on there. And that way you can plug a prop plug right into it and also give it 5 volts without having to, you know, plug it into anything.
Yeah, so there's a prop plug, 4 holes for prop plug, and then what's the 4 dip switches again? You said the first one is for the LEDs.
Yeah, the first one can disable the LEDs. And then the second one is flash enable. And then you have the pull up and pull down for P59 to select boot mode.
Very cool.
Yeah, that's all you need, really. I mean, it's everything that you might need is on there. Now we have another one underway that is going to have 2 hyper RAMs on it, and we're going to move the flash up above the chip. We might not have to make this thing any taller, and then we're going to put 2, and we'll move the dip switch up there too, and then we'll put 2 hyper RAMs where the dip switch and flash are right now, and they'll be complete. All their signals will be separate, so that we could run both of them concurrently with, you know, different activity. And by the way, you know, Jan Omani on the forum, he messaged me and said that he discovered that TI makes these little chips. They're like 20 cents each, and they are super low impedance muxes. And they take like, I don't know, several 10 microseconds to switch. And I realized what they are is they're simply an NMOS and NFET between A and B. And the reason it takes long to turn on is because they have a charge pump on there that super biases the gate voltage on that NFET to make just it's like a 11 ohm connection between A and B. And then it's set up in a mux fashion. So what we could do, we could put some of those on the board and actually make it selectable. So you could route those pins that would otherwise be going to the hyper RAMs. We could route them down to the edge fingers on the card, which is kind of cool. I mean, it wouldn't impede the path very much, and it would allow you to use one, none, or both of the hyper RAMs and get the pins back on the connector. But otherwise, if you're connected to the hyper RAM, those pins will be high impedance on the edge fingers.
So next up is the P2 Edge breakout board, known now as the JonnyMac. And this idea really came from a sketch that John dropped into the forums, and Chip worked with Michael on this extensively. Chip, do you want to go over it real quick?
Yeah, it is what you see. I mean, we have 4 sets of double headers, so we can take the boards that go on the P2 eval. And we also have some, you see those little 4-pin headers midway down the breadboard? Those are for servo connections. And we're gonna get like I think a 2.5 amp 5 volt supply to plug into this barrel jack up on the left. And there's no regulation on this board. So we bring in, 5 volt supply. It might be 5.5 if it's unloaded, depending on how good the wire is that connects it to the wall pack. but then we have a power switch, a power LED, and a reset, place for a prop plug. So you could build stuff pretty easily on this breadboard and also utilize the same all these things that we make.
The adapters.
Yeah, the adapter board.
Yeah. So you could plug the P2 accessory adapters here, and then if you have clicks, you'll be able to use our click adapter, which covers 2 of these. So you can plug in up to 4 clicks and a bunch of servos.
Right.
Very awesome.
You guys like this? Is this what you wanted?
I'll
Hey,
take
Ken.
I like it. Yes, definitely.
Yes,
Okay.
that's great. It's great. I'm happy to see this the servo on there too.
Yeah, me too. And that's also good for our 3-pin sensors that we make.
And you see those big
Like I
caps
said, I'll
there?
take 3.
I can't wait to sell them to you, Roy.
Those giant caps, I think they're 470 microfarad or maybe 1,000 microfarad each, but they're just big bypass caps on power for the servos. So that 5 volts comes in here from the wall pack, and then it goes to the servos, and then it goes into the P2 edge where it's filtered and regulated to 1.8 and 3.3. So this is just kind of it's just a wiring board except for those caps. Those are the only real circuits on it, and then the LED. And then some switches, of course.
Cool.
I was going to show something else we were working on. Let me see if I can.
Okay, while you do that, we'll roll through the rest of these pictures. Then I'll get out of the way.
This thing is 8 inches wide, by the way.
Yeah, for a while it was called the Baguette board. Another perspective, and he wants to see the back of it. The back is very unique. Okay, all right.
Is it like 3 inches wide, 8 inches long?
Yeah, it sounds about right. Yeah, it's like
Yeah.
yeah, double most of our boards. Okay, so on the back, this is every single one of these is a special edition, and this is what you will see.
Nice.
Oh, very cool.
They
Get
made
off.
me do it. I didn't ask for this. They made me give them that signature.
So we all get a Hollywood star's signature.
That's right. Now, we know that John has a big ego, but this is really our idea. And we think it's extremely important to recognize everybody because it's so many contributors all the time. And John has just done wonderful with sharing his ideas and his code examples, and we all learn from them. This is just the least we could do.
So is this going
To be fair, it
lit-
was an awesome idea that he shared.
Yeah, awesome. He deserves it.
Is
All
this
right.
going to be limited edition?
Like Patrick Nagel prints
Yeah.
or a Thomas Kincaid print, everyone can get one. There's also this coming for the breadboard only people.
Okay, that's not just me saying it out of focus, right?
No, it's pasted out of a Google chat from somebody. So it's looks like it's the vertical header, and then you can also plug in on. We'll give you the sockets, and you can plug in the P2 accessories or the click adapter over here and a power jack, and then you can populate one side of these and plug it into a breadboard or both. Okay, I see some heads nodding up and down there. That's good. All right. On this subject, so we have these 24 clicks coming into inventory, and you guys chose them a while back. There's a list on the forum somewhere. And these are a great way just to start doing stuff. So we'll have them. Mauser has them. DigiKey has them. And JonnyMac has 24 of them on his desk right now. And I'm trying to talk him into writing objects. So, John, anything to say about this stuff? And do you want to show your RTC? You unmute yourself first.
Can I share my screen so I can show you what I
love
have?
that. Right over to you.
How do I share?
Click on the green button in the middle and the bottom.
Yep. And well, I probably should do the application.
Yeah, do the app.
Well, let me start here. So for those who haven't seen it yet, this is a Rev C eval board, here's the click adapter, and there's a click. So that gives you an idea physically of what's going on with the clicks. All of the clicks, you'll notice they have, I never counted the pins, I guess there's 16 pins. What they call the micro bus is actually a collection of 3 buses and a couple of signals. And we'll look at that in a second. How do I share something else, Ken?
Then you just go down and do a
A
new share.
share. Okay, there we go. Okay, so hopefully you should be seeing my my IDE.
Yep.
Okay. So because I'm very template oriented, I like to do that. I thought the first thing I should do is create a template that anyone, including me, can use to build microbit objects. The click object. So this is the template. And I even put instructions in here what to do with it. You'll erase this part when you're done. But in order to make this stuff educational, I went ahead and put a diagram in and showed this is the orientation of the pins that are on all click modules, but not always used. And they're offset from the first pin of the adapter. And this pin is always going to be on an, what am I trying to say? 16 is a common denominator. So it's going to be 0, 16, 32, or 48. Although I don't really think you can put a click adapter into the upper group. What I've done then is to make things easy. These are offset constants for the pins for the things they do, like SDA, SCL, etc. So these match this number here. And then I've taken some of the objects I had and I created a couple of new ones. These are all very small versions of these objects. They do just the basic things. So this is just basic I2C. This is full duplex serial without any numeric formatting or anything. Just transmit bytes and strings and receive bytes. That's it. Basic PWM or analog in and out, and basic SPI. This SPI, because I don't know what all the modules do, I did this version in, let me compile this so I can open it. This SPI doesn't use smart pins. I did it in assembly, inline assembly. That way, this object can support any SPI mode and any number of bits, and it takes care of the bit order stuff for you. You know, when you're using the smart pins, it actually takes a fair bit of code to set up smart pins. So if you're just doing small transactions, it doesn't make sense. Anyway, I've got all those. The one last thing I think I need for this collection of small objects is the ability to read a frequency coming in. So I just need to figure out how to do that. And then this template, you know, we'll put out probably by the weekend. So anybody that wants to start writing spin objects for clicks can do that. And they'll have the stuff that I'm using. Here's an example of the RTC module, which is what I showed you in that picture. Now this is not complete, but it does work. So here's what I did. You know, I put in the name. This is in the instructions. I've marked which pins, you know, with an asterisk are getting used. So that helps people that are looking at your library. Even added a little additional information here. The thing with the clicks, because of the way things plug in and the offsets to the different signals, the start method only needs to know the base pin. And then you can configure the pins that are used from there. So in this case, the interrupt pin can be used for an interrupt or for a square wave. Same thing with these. And I'm normally not using these pins, but I want to be able to clear them since they're open drain outputs. We don't want the propeller making those high when the click is making them ground. And this is calling the I2C object. So you can see the only of that group of small objects that I use is I2C. And then the rest are just the methods. Now I don't have them all done, but I can show you in the demo. Here's a very small bit of demo code. You can see, you know, there's the use, here's the start, and then this code. If I run this, is my PST showing, or do I have to share that separately?
You'll need to share, yeah, that separately, or share your whole display if they're on the same monitor.
Okay, yep. Yep.
You might be able to drag the PST.
There you go.
And sure. Let me try again. Why does this, yeah, I promise you this works, but I don't know why it's not working now.
Demos. At least everybody here understands.
Yeah, what the hell? This is just annoying. Yeah, because I even texted you, said, hey, the clock works. It does work. Why it's not working now is a mystery.
It's something really simple.
There we go. I just needed to
Nice.
So anyway, the neat thing about this particular RTC is it's got a thermometer in it. So if you want to know the general temperature of your surroundings, and now it's not 86 degrees in my apartment, I can assure you. That's even warm for a guy who grew up in the desert. But I have one of, oh, can't see it. I have one of these laser thermometers, and it says 83 according to this thing, and that's we're saying 86. So it's fairly close. That's inside the chip, of course. But I'll have this, should be done in the next few days, and hopefully that'll start as a model for other people that want to build, you know, clicks. Like I said, Ken's not lying. He sent me a big box of these things. Some of them I don't even know what they do or what they are, and I'm sure there are, you know, people in the group that have specific interests that they'll want to do right away. So hopefully the template for those of you that are spin programmers will be useful. Maybe the C guys will make one that's identical for C, and that will help the community use the clicks.
So Eric Smith, could you envision then accessing the spin code through the C compiler?
It probably already works. I'm not sure. I haven't tried it. But.
Very cool. Well, if your time totally frees up and I can forward you a box of these to look at, or someone else here that is working with C, I will do that. Because JonnyMac has a house full of hardware.
I do.
When are the little adapter boards going to be available?
We actually have them. So like if you guys want this stuff and it's not on our website, we have them in stock. We just are holding out for a new website. So if you want them, if you, for now, just email me. I'll give you the part number and you can call it in, or I could just put a few in an envelope and send them to you to get you going. That's actually the easiest thing for me to do rather than do a sales order. We're going to charge like a couple bucks for them. So if you're doing some development work and you want to get out of the game, we have the click adapter and the WX module adapter.
Yeah, well, I'm getting close to another update to the Simple Tools for Flexi.
Okay.
Simple Tools header stuff, which includes I2C and SPI and some of the things that are needed for these clicks.
All right, that's perfect.
So I might be able to do a few C modules, but I
Okay.
wouldn't want you to send me the whole pile of 24. You can just, like, if I can just get the adapters, I can buy my own clicks.
That sounds good. In fact, so yeah, here's the list of them. You know where this is, Roy, on the forums.
Yeah.
Just give it a look and tell me which ones are of interest. Just send me a message and I will drop them off to you. We have them in stock.
Oh, okay.
They're all in Parallax, just not up on the website yet because we're putting them on the news site only, so we don't have to maintain two sites.
Yeah, understood. I'll research them because I want to get ones that use the different buses. I'll just pick 3 or 4 that have one's I2C, one's SPI, one's serial, you know, so I can mix and match.
Right. I mean, another option is just to use the spin object too.
Sure. But I mean, I already have I2C and SPI working and serial works. So it's just a matter of writing little C demo programs that talk over SPI or serial or whatever to these modules with the appropriate pins.
Just to note, Roy, that CAN adapter, the SPI on there is full duplex. So if your SPI object doesn't have, or library doesn't do full duplex, you'll want to add that in for that particular device.
Yeah, one of the things that I've been thinking about with the whole Simple Tools conversion is a lot of the things in there are very simple. They're meant for educational purposes to look at the code and whatnot. They're not necessarily optimal and they aren't as featureful. So I've been thinking about like making a not so simple tools version of the same stuff that is enhanced with better features and utilizes the P2 better.
I just pasted into the chat the list of clicks as well. Okay, so before we move on to Chip, actually Jeff has something to share. New objects posted in GitHub. The latest one was the ESP32 object, and this is using the default firmware in the ESP32. And this is one of the clickboards, but there are also a lot of real cheapies on Amazon for a couple bucks, which seem to work. And I haven't had any feedback on this yet. But encourage people to try it out and let us know. See what can be done with it. And Jeff, Martin, did you show up yet? Okay, so I wanted Jeff also to do a quick walkthrough of how to get objects off of GitHub, because when we took the OBEX down, we disappointed a lot of people and we forced people to GitHub that didn't want to be on GitHub. But the reason we took it down is because we couldn't maintain it. And ultimately it just resulted in us having a lot of staff just to run systems and things that were becoming a burden. So we hope we made the right decision for the long term. But we're still warming up to it. I could see from the forums. Jeff was going to do a quick tour of just how to use it in regards to parallax. So when he reboots, we'll bring him back and he can guide us through that. Or Roy would be able to as well.
Just as an aside, I did find it wonderfully interesting trying to clone the repo and actually get copies of things locally. That was a challenge for me, by the way. It's organized. You have something to do with a large file system or something attached to the repo?
I'm not really sure. We'll wait for Jeff. Now, me not being I'm the farthest thing from a GitHub user, but I'm able to just grab the whole zip and download it all. So
Okay.
I think you guys are trying to, I think the challenges actually happen when you try to use GitHub for its intended purpose, right? Yeah, which is going to be beyond the scope of what we can do here. So what's missing then is probably the feedback mechanism that existed with the prior OBEX.
So when you just want to get them, you don't need to fork it. You can just download the zip like Ken said. But if you want to submit changes, then you need to fork it and then use GitHub to update your fork and then do a pull request back to Parallax.
Certainly I agree. That's the recommended way, and that's what I was trying to set up for. There's an additional something to how that repo was configured though, that requires Git extensions be added to your local system to make that work. And if I was prepared, I'd be telling you precisely what it was, but
good.
I'm not.
Yeah, let's see what's up with that. Jeff knows all about it inside Parallax. So rebooting. Also coming soon for the Europeans especially, and for those that shop here, P2 products. So I think that's all for the housekeeping until Jeff comes back. Chip, do you want to share the debug stuff?
Yeah, I wanted to be further along. I found some last minute bugs. One, like just this morning, when I was parsing the stuff coming into the debug displays, I was not accounting for every possibility, looping and as long as there was anything left. And so I was locking up, and it took me a little bit to figure out what was going on. So I got all that fixed, but I haven't gotten much else done. But I have been working on the documentation. Okay, but before I go to that, I want to show one thing. I'm going to try to share my screen here. Here we go. These are going to be here tomorrow. Can you guys see these? So the Gorsel thing is actually in this later version of Silicon. It was designed to work. You know, ultimately you need to resolve an X and a Y, but it only takes 3 outputs to do that. So I'll have these tomorrow and I'll try it out. But the idea is that we output, instead of phases offset by 90 degrees, they're offset by 120. But where they mix down on the bottom board, you see it's upside down. There's that little like, looks like a peace symbol. That's the pickup. So you'll move your finger on the top of the board where you have those three segmented kind of rings. So it's like a segmented ring. You move your finger around there and you couple those, the outputs coming off of those arcs down through the FR4 onto that pad on the bottom of the board. And we should get the same XY proportionality we get with the other, but this is only going to take 3 output pins and then 1 input pin. And there's also so much stuff we haven't even really explored yet because I've been working on tools. I haven't been able to do it, but this Gorsel thing should be able to do all kinds of interesting stuff in the future if we can just figure out, you know, what to do with it. But it can not only resolve, you know, X and Y, but you can take, you can have up to 4 inputs and you can tell whether to ignore, add, or subtract each one. So I think there's some like potential for some interesting 3D stuff, but we'll get there. I'll get there a little later. All right, let me stop sharing that. Wait, I'll keep sharing that. I'll go to the documentation now. Let's see. Okay, so I've augmented. I've made some new part to the spin document. I started explaining kind of from a ground up approach how the debug windows work, and you know, kind of what's up with them, how to talk to them. I asked to put some stuff in here about the syntax, but I was able to, I think since we last spoke, I don't know if I mentioned this last time, but I got some program that I can throw a whole bunch of bitmap files at, and it will compile them into an animated ping or GIF. And I found that the GIF was pretty big.
Hey, Chip, quick item before you go on. Can you go down to share screen, advanced settings, and then zoom in on this?
Okay, advanced settings, hold on.
Yeah, the YouTubers get very irate with me over and over again when your 4K monitors are used like this.
Right, okay. Let me, let's see, share screen.
Advanced sharing options, and I think you can do a share a portion of the screen.
Okay, I'll just, oh wait, okay, portion of screen. Okay, select a window. So where's my?
Sorry, everybody, to put you on pause for a moment.
Okay, here we go. Can you see that?
Yeah, it's sort of, there we go. Yep, now you can scroll. It's a little bit, you're shorting the right side of it though. I think you shared not enough.
How about that? You should see a little thing that says my scope.
Yeah, can you kind of zoom out and then carry on? Maybe
Well,
that'll do it.
Zoom out more. I mean, is that legible? If I go down here, do you see these birds? And
Well, we're just missing the right half of the page.
the right half of the page.
But
How about, does this look proportioned properly?
it's better. Maybe just do quick control minus and that'll bring it into
Control minus.
perspective.
I don't know that that's doing anything. Anyway,
Okay, this is I think better anyway.
all right, now if I move up, can you see that little sawtooth wave?
Yeah.
Okay. So anyway, I started documenting how these things work. But there's some site called easygif.com, like easy GIF, and you can take your GIF there and it'll compress the heck out of it, so it becomes as small as like an animated ping file. So I was able to use that. If you can see this, see this animation here? This is a GIF file that I put into the documentation that shows the, like for the bitmap display, the various trace patterns, you know, how you provide pixels to it and which way they go in and whether it scrolls or overwrites. Can you guys see that okay?
Yep.
Kind of like a little 8x8 thing. Anyway, I've just been working on this. I think now that I think I should have in a couple of days, maybe by the end of the week, I should have all these debug things documented. But I've added into the debug, like for save, you can actually save the screen contents. That's how I did this. You see how there's like 16 windows here? I just used the save to each time it updated, it would save a whole portion of the screen. And then I could build those into a GIF so I could document things. So the documentation can now have all sorts of nice pictures that really explain, like if you look at this little program up here, you get the idea that code, that little program creates what you see in that window. So that's really, I wish I had more. I was planning on having more stuff ready, but everything is, it's kind of going from out in flux to back together and then documenting. So Ken.
Yep.
What else have you got on the program?
Questions for you. Well, I know one customer is asking how to generate a sine wave, and
yeah, okay, I started working on that. I made a little program here, but we need to put it into an object. Does he want to make like just a continuously running sine wave?
he didn't say.
I just was looking at experimenting with inverters, making home inverters.
Okay, all
Probably
right.
a career project.
I understand. Okay, well, I made, while the meeting started, I worked out a little program that generates some sine waves. I have them, let me see if I can get this thing. I have them on the scope now. I don't know if you can see that, but I can't stretch any further. And the code is right here, but I can share that. What I'll do, I can wrap this into a spin object or a little spin file so it's easy to work on. And then you can modify the frequency. But it's going to take me like probably another 15 minutes to get that organized. So I don't know if we'll do that while we're talking today, or if there's a lull and you guys are discussing things, then I could probably do it. But we can talk
This
about
is probably a career project for me. So I'm talking years. 15 minutes is great.
Well, maybe Chip, you could work on that a little bit, and we'll have Jeff do the GitHub tour,
Okay, yeah, that would be good.
and then we can do whatever after that. So Jeff, your computer came alive after half an hour, but you're still muted.
Okay, hopefully you can hear me now.
Yeah, welcome back.
Everything was fine. Things were humming along, and then suddenly JonnyMac cut out, and I thought it was him, and then realized it was me. I couldn't even get my mouse to move. I don't know. The computer gods are not on my side today.
Well,
Sunspots.
Jeff, I'm a trained professional actor. Do you want me to do it again?
I'll watch the recording.
So Jeff, without doing a full GitHub educational tour, which is sort of beyond the scope here, and there's a lot of stuff on YouTube about it, it would be good, I think, well, the group here could tell us what they would like to know about using GitHub, from just a very simple access to getting our objects.
Yeah.
And then Stephen Morocco brought up grabbing one and then returning it using the repo. Maybe he'll let his words describe what he wants to do, but
Okay.
so you want to share screen, show us where objects are held?
Yeah, let's see. Let me move this out of the way.
Just to be clear also, I was successful in doing what I wanted to. I put the terminology in the chat for everyone. There's something special about this repo. Hopefully, Jeff, you'll explain why that happened and why it's used. Thank you.
Okay. Let's see. Hopefully you can see this. It looks like the screen sharing feature kind of changed a little bit. Is everybody seeing the Propeller site? Okay. Are you able to see this folder here also?
Yes.
Okay. What happened? All right. So right now we have all the objects, the old objects from the Parallax Object Exchange or Parallax Object Exchange, Propeller Object Exchange system that used to be a dedicated system that we custom built, all stored in this repository on our GitHub account. And you can get to it. I always just go to propeller.parallax.com for the time being. I know that this will change a little bit as we enhance things in the near future. But as you can see here, there's a, Explore P1 and P2 object exchange here. I'm just going to go ahead and click on this. And this structure here kind of mimics what we had on the original object exchange, except that in these folders, there's that's not a really good example. Let me look at something that probably has some more items in it. So in these little folders which represent a category, there's a list of existing objects for, in this case, the P2 that match that category. And you can actually click on one of these and it will take you right into the folder where the files are stored. And if you look up here, there's some breadcrumbs here, a little path that shows you where it actually exists in the repository. So this is all of them actually exist under this all category. So if you were to look here, you can see everything that's here, but you can't necessarily understand from just this view exactly what they're for. However, if you dive into each one, you can see some description provided by the object author about what that is. Now, ideally, we would love it, if we could just go right here and just like right-click a file and and save, or right-click a folder even up here and save the whole set of objects. Unfortunately, GitHub doesn't have that ability presented. Excuse me. There are a couple of things you can do. One thing to note is that currently there's not a whole lot of activity, so things don't change on here very often, which kind of makes it, I realize that we want to have a better interface for this, but still use the repository as the back end because it makes for a great version control system. But I'll tell you what you can do here. If you want, if you're not a GitHub user, you can jump up here to this code link, and under this code button, there's a download zip, which will actually take the whole entire repository, zip it up, and provide it as a download. So that's one way you can do it. Also, once you dive into those objects, I'll go back to one of those. If you scroll down here, there's a little description for this is the P2 community section. And I've started providing a little link for an actual download. So this is, if I click this, it's going to download a zip of everything as it exists in the so-called P2 object exchange currently. And I'll keep that up to date. For those that are more advanced GitHub users, that link actually goes to the releases page, which I'll point to here, and there's a P1 and a P2 zip archive right there.
Jeff, can you clarify, is that code button and then download the zip on the right side the same as going to the bottom?
What's on the bottom?
Yeah, I think you showed two ways of getting to the same code zip.
Oh, no,
so
it is
this way.
It is different. So this way that's provided by GitHub is actually archiving the entire repository that includes everything in addition to these object exchange files. So right now you can see here the object exchange files are in this libraries folder in community, and then either P1 or P2. But up at the high level, we have some other things, some initial resources that were back in some even earlier development for the P2. There's just some source code examples there. And this docs folder is actually assets for what's currently showing on the Propeller website. So this repository actually serves up this set of web pages, including all this information about the P2. So when you go back, or when you go to that code link right here, click this button and click download zip, you get everything that's in the repository. If somebody, well, Git users, like open source developers typically use some kind of version control system, and Git is a very popular one. They're used to cloning the repository, and essentially this is a clone without the like the overhead that's included with the local management for the repository. So it's really just the content of the latest set of commits, the latest set of versions of everything is what you get when you click this download. Down here in the link that I provided, like right here, is just the latest versions of whatever objects people have already posted to the repository for Propeller 2. So it's a slightly more targeted zip.
It's the code libraries.
Yes.
And
Yeah,
up
so
top
in
includes FPGA images, documentation.
Yeah, in fact, you can see
whatever.
I clicked on it here. I mean, I downloaded it here. I will show you what that zip looks like.
Well, Stephen, I take it back. I was doing it all wrong.
What were you doing?
I was downloading the whole repo every time I wanted a serial object.
Oh, well, that was one of the only ways to do it unless you're a Git user. And I can show you how to do that also. By the way, this is a common problem with GitHub wasn't really meant to be used the way that it is a lot today. And Microsoft, who now owns it, has been making a lot of enhancements, some of the features of which we intend to use as soon as we can, that will make it more automated, make it more easier for us to provide a nicer interface for things like the object exchange if we want. But previous to this, what everybody did was always get the entire repository, including all the old versions of everything when they used it. Of course, most of our Propeller users probably aren't in that same camp, although I think certainly some of us are, like Roy is probably very familiar with Git. So anyway, yeah, you can see here that this includes everything that you kind of saw through that GitHub web interface, but it's all files on my, well, right now in my zip archive, but I could extract it and get to them through my file explorer. Yes, is that Stephen?
No, this is Carol Moore. I got a question. I tried to do this initially. Go into one of those folders that has a zip file inside the folder.
Okay, like this one?
Yeah, try to unzip it. Whenever I tried to unzip see, I did a download like that, and mine are always empty for some reason. Have you ever ran across that?
No. Do you happen to remember the archive that was like that?
Oh, I did it about a week ago. I downloaded, I did what you said, download the code, zip file, downloaded the whole archive and put it on my machines. And I tried to unzip those files and they came up empty. So I initially, after that, had to go ahead and I just cloned the repository and then use git bash to do the local archive on my machine, and it worked fine that way. Okay,
you just made me think of something that might be a problem I didn't foresee. For those zips that are in there, we use an extension to Git called, oh, it escapes me now. LFS, yeah, large file system.
That's where my question came from, because I ran into the same problem initially.
Yeah, so those are stored that way. So maybe when I do this, and I'll go ahead and do this, I don't know how long it'll take. Maybe that's not actually giving us because what it would need to do is grab all the actual content. I would have thought that they would have hooked it together so that it provides that. And I apologize, I didn't know that that was happening because, okay, here we go. I don't typically use it this way. I'm like down in the ditches digging around in my local repository. So let's check out some similar place. Where was that? Oh, there's one. Oh, there's another one. Ah,
That's what I'd encountered.
that's what you've encountered. Okay, so that is definitely solved by the link that I provided. So sorry about that. I didn't realize that that was happening. So if you did it this way, where you just go to, you know, the root of the P2 section, and then download it from this link, that will give you everything. Or if you clone the repository, and does anybody want me to show you or how to do that?
Actually, you know, when I couldn't do it that way, I actually did the forking the repository to my local account and then downloading it to my local machine. And I actually like that because with Git Bash, if I change a file on my local machine, it actually does version control. It knows that I'm out of version with what's up on my Git. And then using commands on my local machine, I can sync the two, and then I can sync it with your repository, which is really interesting.
Oh, and that's with just Git Bash?
Yeah, that's using and it's the commands on your page that you have your instructions. If you follow those commands, it'll do that.
Are you talking about this, the contribute?
Yeah.
So here, if you click this, it goes to a little wiki that's inside of that same repository?
Yeah, if you follow those instructions, I was able to follow those and actually set it up, and it works really well.
Okay, I'm not familiar with using it that way, so I'd love to see that sometime. I guess I'll have to try that out. I typically use command line all the time for accessing repositories, and honestly, I'm not a command line guy. I don't tend to live there, but I love GUIs, but I have yet to find a GUI interface for Git or GitHub that I really love. Every one of them has let me shoot myself in the foot multiple times. And I can do that just as well with the command line. But over time, I ended up learning enough about the command line version of Git to feel comfortable with it.
Yeah, I've been using the Git Bash, and it seems to work for me. The only thing I can't get it to work right, or I don't know if it's me or not, and that's the pull request that I sent an email to you a while back about.
Yes.
So I have some stuff that I've contributed, but it's still open. It's still an open pull request, and I don't know how to get that resolved.
Is it? Oh, I never received. Yeah, that was 7 days ago.
Yeah.
Oh my gosh, how embarrassing. So normally what happens is, as soon as somebody submits one of these, I receive an email, and as soon as I have a chance, I go through and check out what's there, review the code, and then I'll actually do the process here. I'm going to trust you that you've done everything.
Well, don't do that.
Well, anyway, maybe you guys might want to see this anyway. So I can go here and click Files Changed, and see that on this README here. Oh, this is one that did I help you submit it the first time?
Yeah, you sent me an email on how to do. I had a hard time understanding how to do the pull request, and you sent me an email, and I followed your instructions, and it worked just fine.
Okay, and then this one is an update to that. It looks like.
Yeah, that was me trying to figure out how to get it to work. So that's not really an update. It's me just trying different things.
Is it not something that you want merged in?
No, it's ready. It's ready to go.
Oh, okay, because I don't see anything wrong with it. I'm just going to go ahead and merge it in now.
So Jeff, a quick comment on the zips inside of the code download.
Yes.
If you unpack the zip file and open it in a text editor, it's got a message about git LFS and the size of the file and stuff. So it's like it's taking the zip and just giving you information about it and not the actual file.
Yeah, because that's how it actually stores. So it stores basically a path and a hash, I think, to the actual resource.
Yeah, that's what's in that .zip file inside the archive.
Yeah.
So I'm curious why you needed to use Git LFS at all.
Well, we started using it because there, for one thing, on the original Object Exchange files, we of course supported images and little videos and stuff, and so we tried to preserve that. And Git isn't, it's a source control system. It's not, or a version control system. It's not really good at managing binary files as far as.
That's the biggest complaint from most developers is binary file handling.
Right. Yeah, it's not very efficient at storing those. So we started using LFS, which again is an extension to Git that, I don't know, it came out a few years ago and it's really been pretty heavily adopted recently. And that, I believe, the way it works is they store the actual binary on outside of the repository, but in the repository they store this little text file in its place with the same name. So that zip file is probably just a text file that tells Git LFS where to go find that resource. So when you do on the command line, like a Git checkout to check out a particular commit, it goes and grabs those resources and populates your working folder with the actual binary file. In this case, it would be a zip. So yeah, that's something, I guess it's up for discussion about how we can handle that. Also, though, the way it is, there's, when somebody archives something, I typically leave it as a zip if I'm, managing it for them and putting it in to the repository. But there are, of course, that means that there are copies of some of the same objects that are maybe outside of that folder in some other folder that are kind of standalone. They may be used in this little demo that somebody wrote for a different object, like say a serial object that just outputs stuff to a debug terminal. So that's not really quite optimal. Haven't figured out how we should really address that going forward. But
I would like to kind of make some harsh comments here. I think you should probably build something like that into the prop tool, that somebody who installs the prop tool can directly access those library files somehow.
Right.
Because
yeah.
it's a lot of work for people who just want to use some tool to install Git extensions, get used to that command line thing. I mean, I'm not doing that. I'm a core programmer. My source is not outside in the world anywhere.
Right.
They wouldn't allow it.
Yeah.
But if you could build something into the prop tool, like the library folder, but kind of showing GitHub and downloading files directly.
Yeah, that's an excellent idea. I can imagine that we could, make it pretty easy to browse through the existing files and just go pick a specific one that you want, rather than having to download the whole world of objects.
And
but still have that option too.
Stuff, because a lot of people here are not using GitHub, and they're very, very happy with the OBEX, even if not integrated. It was easy to get kind of 4 duplex serial out of that, and put it on your local folder. But it would be really nice if you could put that into the prop tool, that you there basically directly access the Git file system and download files.
On that note, it would
while compiling, it's getting the stuff out of GitHub instead of from your local file system.
Yeah.
Mm,
Yeah.
You know, I mean, I'm just dreaming here.
All right.
That's
I
how
hear you. No,
the,
that's a good idea. I like that.
Jeff, if I may too, an ability to get it through the tool would also give you the ability to pull latest updates for things you already have installed, which might be useful as well. Not to add more to your plate, but you know.
Yeah,
Right.
I mean, that's how the Apache NetBeans tool works now. Is it's got a link directly into GitHub. You can write all your code and sync it up with GitHub directly from within the IDE.
Makes sense.
Also, Jeff, another thing, if you aren't building those releases through automation, those zips for the P1 and P2, you certainly can. Whenever you do a final commit and then you tag it with a release number, the automation invokes and then can generate those zip files for you automatically.
Yes, and that's what I'd like to get to. One thing I mentioned earlier was that there isn't a whole lot of activity, so I've put off automating it so far because it really doesn't take very much time so far. But certainly we're going to need to do that because we expect more and more objects from everybody in this meeting and outside of the meeting, right?
Now you speak to an interesting aspect because part of the reason I do the automations is so I don't have to remember when I've been away for a long time what the steps are. And so
You'll have
even
to
at
make sure-
infrequent, it'll automatically do it for you through automation, so you just don't have to worry about it anymore. So
have to make sure that automation is Git LFS aware, or you'll get bad files.
absolutely.
Right, or we have to use a different solution for Git instead of Git LFS.
And I have honestly to say that's not a lot action there is a completely wrong sentence, because look at what JonnyMac is doing in the last couple of weeks. I mean, come on.
Well, okay, I guess I didn't mean to put it down. Certainly, yeah, there's a lot of objects there provided. I mean, JonnyMac was on fire, delivering things multiple times a day for a while.
Yeah, and I mean, look at what you have at content. Most of them start with JM.
Hey Jeff.
Right. Yes.
Is it possible to configure the Git LFS to not do its thing to zip files? And
Sure.
only do it to everything else?
Yes.
Because then that would fix the code, download everything to have proper zips inside it. And you don't really need to version zips. If you can configure it to only keep the most recent zip, that's fine too.
That I don't think we can do because it would have to rewrite the history in the repository.
Oh, like if you just change the config so that from now on, when zips get added, they don't keep version. I don't know if Git can do that. We do it with Perforce all the time. You can specify by file type whether to keep no versions or only a couple versions or keep them forever. You can configure it.
Yeah, I don't.
So
I'm not aware. Yeah, that might be possible. I'm not aware of a feature in Git to do that, so I'd have to look that up and see. But
I was thinking more the Git LFS, which is handling the binary files.
Oh, okay.
It could probably it might be able to be configured to not keep lots of copies of zip files and binary files. Like for most of the art files in our depot and Perforce, we set them all to like 5 versions max, because otherwise our Perforce database would need terabytes of storage.
Right, right. Yeah, and that's the reason that, I mean, for a long time, people never, they never inserted binaries into repositories unless it was something really small and not likely to change very often, or they did it by accident. And ended up making the repository huge, which, you know, is a problem on the storage side for wherever the centralized resource like GitHub is, but also for new people that are cloning it, because until recently, when you cloned, you always had to you got the whole entire repository. I think now you can actually do a sparse clone or sparse checkout. Can't remember how that works.
Okay, Well, shall we
Okay.
get on?
Sure.
All right. So for those who are still unsatisfied with the file sharing process we have, just keep telling us what's not working, okay? And we will evolve.
We need to get David Zeman's wrapper that uses the GitHub API more fleshed out, and then it will
Yeah,
be for easy users to get individual objects.
I agree. I thought he
Yeah,
was on a
you
nice.
should link on David's source control, no, that build server, because he builds all the tools as soon as they kind of change, and it's all of it is there, flex going, everything.
Okay.
Yeah, maybe somebody could post that link in for Jeff and others to see what he's doing.
It's on David
It
Sherman.
was in the on the forums in the
Sherman has
general.
that build server running, and it builds prop GTC and builds flex. I mean, all of the products, P2 loader, everything is there, built from Git automatically every time it runs. Somebody changes something, it will automatically. It's already there. You just need to kind of link on it. In his signature is a link on his build server, and you can kind of grab all stuff built for P2 and P1 mostly. I mean, not Prop Tool, but X or the other guys. No.
So just to be clear, people seem to really like that. They'd like us to direct to it or to use it, right? As an interface, because it solves the problem, right? That's what I'm hearing.
It solves a lot. He has a nice OVX-like interface for your current GitHub, and he is doing all the builds for the, even some guy here lately providing a Mac to the Mac binaries, and everything is on his server.
Yeah, so I shared a link to the forum post on his unofficial OBX thing that wraps the GitHub API. Yeah, and what Michael is saying is David also has the Team City continuous integration thing going, and it like builds OpenSpin, and I think he's even got it building Flex GUI now, or at least parts of it, and all the other community tools. It builds them anytime somebody checks in a new update in the GitHub. So it's pretty nice.
And Parallax should kind of provide that link somewhere that somebody can grab it. I mean,
Yeah, it could solve some challenges of ours for sure. So Jeff's looking at it, and we'll see if we can incorporate this into what we're doing here as the front end. I've followed this as well. It looks great.
I mean, it needs some UI prettying and niceties, but the basic functionality is there in what he was showing.
Just, am I missing something? Because I went to that thread and clicked on the link on the line. So please enjoy your first look at my unofficial OBX. And what appears there is just a brief explanation. I don't see anything else.
I think it's in his email signature.
Yeah, the main server is this build server, that Team City server which he is running, and there you basically have all current versions of all GitHub tools other people provide. Prop DCC, even the new LLVM C compiler, C++.
Well,
basically Clang for P2, where somebody, even that is already there. David is doing a nice job in collecting and providing binaries built.
I think what Jeff is looking for is the actual link.
Yeah, the link is in his signature, but it's currently not working. It just has the title line at the top that links back to the GitHub repo.
Okay, that's what I saw.
That same link was working at one time. It's probably just out of date because you've been updating the GitHub side, and he probably has to change something to line up with whatever changes you made on the GitHub side.
Is that the ci.zeman.name link?
No, there's one that's under his signature. It says new OBX.
Right. Yeah, this is not what I've normally seen here.
No,
as
that
well.
is the OBEX thing.
Yeah, but
he is
it's not
working
working.
on that. No, he is working on that. That's basically your web interface for the Git OBEX.
You could probably just message
the
David.
main thing you need to link to is build server. The Team City server he is running. There's also a link in his signature, and there you find all the prop GCC for Mac, for Windows.
That's
for
a separate
Linux.
thing.
I mean, it's a separate thing. That is OBEX is another project he is doing, and he is working on that, but it's not ready yet. But the other stuff is working completely since a long time.
Yeah, I think what Michael's suggesting, Ken, is that you just have a link to the Team City downloads for the various stuff that it builds, because he builds, like, there's OpenSpin for Windows, Mac, and Linux in his builds, and he does prop GCC, and he does all the various other, there's like 8 or 9 things that he's continuously building whenever people make changes.
I see
If
that.
you just had a link to there.
We actually have a link to their, it's in the, well, there's a software section on that page, and mind you, this, is kind of changing all the time.
Come on, get real there. Put an iframe in there, and put it directly on the site that you can kind of click on it.
Okay, we'll bring that into our links and make it prominent.
Also, Jeff, you might want to PM David Zeman about the new OBEX thing to see if he can quickly update it to be working again.
I just made a post to him.
Okay. Yeah, I'm curious maybe it's just something he's working on that made it break. I can't imagine what I did that would cause it to break.
So what it did is it went to specific folders and created a tree view of all of the folders, and you could click them and download or view and it would like bring up the source code with syntax highlighting, or you could download that particular object instead of having to download the whole thing.
Okay.
Like I said, it was very basic. The tree was like just a single very tall tree of 1 entry per leaf, and that was it.
Yeah. All right.
Okay, so let's move on. Brian was willing to wait 15 years for a sine wave, but maybe Chip has one for him.
Johnny's been trying to say something for a few minutes.
Well, I was just going to say, I'm not much of a Git user, but I found, because I normally just want one file and I don't want to download a whole bunch of stuff. But if you can get to the file, navigate to the file in raw mode, and then you can right click and save as, and it works just fine.
Yeah, for individual single files.
Because I often just want one file. Yeah, exactly.
Yeah, I neglected to show that. Sorry about that.
I know it's hacky, but that's, again, with one file, I don't want to, I don't have to dig through a bunch of stuff for one file.
Thanks.
Yeah, but John, usually you do things like you have your IC2 file and you have your kind of text output using that. So basically, I don't need to download one of your files. I need to download a couple of them for that RTC chip or whatever.
But I found, Michael, that at least with the stuff that I've contributed to, and Jeff, I'm almost done with a couple of client projects, so I'll get back to writing a lot more objects. Sorry for the delay.
Right.
But I always send a zip file that has the archive, that has the example code and the object code and anything else is needed. Now I've found that those zip files you can download direct without any headaches.
I'm going to try that right now.
It was just the individual source files. There's no download, obvious thing. But I found if you get them, if you click on raw and you see it on the screen and right click, then it will download that file with the proper extension.
Yeah, I thought I had done that at some point, and then It looks like you can also, oh, I see, yeah. You'd have to click on it to get raw, and it shows you stored with Git LFS. Oh, and then there's a download button right there.
Yeah, so for the Git LFS stuff, there is a direct download link.
Yeah, and that is working properly. That might be what I had tried when I first started creating this and thought, yep, everything's working.
You know, one of the things you might also be able to do is have a file in each folder that is all of the spin2 files packed into it, so you can just click it and download that, right? Using the same method you just did. Like you'll have the individual spin2 files for the object, and then a zip that's, this is all the stuff in this folder, and then you can click and download it.
Yeah, yeah, that way somebody could potentially just use that as their source library all the time for whatever tool they're using, and then just go grab it, unzip it, run.
Exactly, and build that into the prop tool.
Right, I love that idea.
Speaking of
Well,
prop,
all of them,
Jeff,
actually.
do we have any updates?
I was hoping nobody would ask me that.
Jeff, we're happy
no.
you're here today.
What, when you called me out on slowing down on objects because of client work.
Oh yeah, of
do
course.
it.
No, I admit, yeah, I've been slow to meet any of my goals for September. I have lots of valid excuses, but I won't bother saying any of them. I am doing work behind the scenes that will benefit everybody.
No way for excuses here. Think about Joe Rogan. You need a sober October.
Yeah, no update yet since version 2.3. But,
yeah, but basically there are a couple of things I like. I personally like Prop Tool a lot. And I have to fight with Peanut now because I tried to get my code running with Peanut and with FlexGUI. And I can't really share much of it. But anyways, I really like the Prop Tool. And I don't really like Peanut. So I really would like to get Prop Tool a little bit upgraded again, and getting access to GitHub from Prop Tool would be, I mean, in compiled process, you know, you just reference a file, it gets downloaded to your library, and then you can use it, you know, something like that. Some easy access to integrate the current version of whatever for duplex serial.
okay.
That would be.
I'm writing all
I'm
this
sure you all that
nice.
Jeff
yeah,
hears you.
Making notes.
I mean, he had to look to the last couple of days even at something totally unrelated to this, other software, other microcontrollers that keep our business going. So he's been absolutely slammed.
As are all of us, really, right?
And there's just him for all of your software, right?
He's it. Yeah, but he knows.
I
He's
feel
got
it.
the queue in order. Yeah.
I mean, Chip is metering away with the debug stuff and Peanut and his work, and poor Jeff has kind of to follow up. Integrate it again. But hell, I mean, basically it is a nice software suite you have. It's just icky still. You know, that Git, we have to have a GitHub integration, and then it might be really nice.
Yeah, yeah.
And it runs under Wine, it runs under Linux. I mean, it is a Windows application, yeah, and you can't run it on ARM. Okay, yet. But basically, you are doing a good job there.
Thank you.
Sine waves?
Yep.
Did we give you enough time?
Yeah, I got it. I just finished it. So let me I'll
That
share my
was
screen.
15 years in computer time.
Yeah, I don't feel a day older, really.
Now he's going to show you some PASM code.
Well, both. So, okay, can you see this window okay?
Yes.
Okay, so this is just a little thing I made where I set the clock to 300 meg, and then I have two of these variables here, right? They're both longs, frequency and pins. And so we can set up pins in spin right here. And then we here modify freak, right? So I have it going from 50 to 60 hertz, which is kind of like, let's go to 70. That's like line frequencies, AC line. So anyway, and then so as I set the frequency, I use a fraction here to calculate a 32-bit adder value for the NCO in the streamer. You have to shift it by 1 because 8,000 is unit 1. 8,000 hex is unit 1, so I got to shift it down 1 bit. So and then I wait a second, and then I step the frequency by 1. And then this is the program here in assembly language that does the work. It first writes a table into the LUT, which is a sine and cosine table. And here it grabs the, let's see, what is this? This is the pins. Yeah, first it has to modify this value down here and install the cog number into it. So it does that here. Then it sets up the pins. It sets the proper mode, turns them on. Here it sets the streamer mode, because it also has to put now the pin number up into this value, into these bits right here. Or actually, I think these bits. Then it just sits here in this loop. You know, once it's running, it's outputting sine and cosine. Then it just sits in this loop, always grabbing the freak value up here, which was set right here. And then it just updates the frequency. So this program, I can run it. Let's see. That's running now. If I take my camera, you can't still see my camera at all, can you?
See the ceiling.
Yes, I see it.
So you can see that scope there?
Yes.
And you can see those waves getting a little tighter. They're going up to 70 hertz. And then they'll now they're back down to 50 hertz. So every second they go 1 hertz higher. So that's an example of using the streamer's DDS mode to just generate. You can actually generate four output phases. I could do sine, cosine, not cosine. But, and then you could use this here in the add pins. We could put 3 there. Then I'd have to modify right down here to add another high word in. Where instead of clearing the bits, I'd have to copy the not of the low word up into the high word, and we get the rest. But
I'm kind of confused here, Chip, because you have in your assembly a jump loop,
yeah.
and you have outside in spin your loop with set frequency from 50 to 70. How and why your assembly code stops going out of that loop? You just overwrite it, or what is the? I mean, actually, your assembly should stop everything and stay there.
Well, what it does is it sits in this loop, and it just keeps grabbing whatever the latest frequency was that was posted. Because remember, when the cog is launched, it sets the address of frequency into point array. So when we do a read long point array, we're like this. We're actually reading this variable.
No, what I mean is that your jump loop doesn't end. So basically the cog is now running that loop. In the outside, you have a repeat from 50 to 70. How does it start again? Why?
Okay, well, because this cog is running in the background, right? It's another cog, and it just runs in the background. and we communicate to it through this variable. So we need to have the cog keep running because we need its streamer to keep functioning. So this here probably, you know, if the PASM program's running in cog 0, this winds up running in cog 1. So this program just really says the setup for the streamer in these first lines, and then here at the bottom, it just keeps updating the streamer frequency with this instruction right here.
Yeah, so the streamer is just going to run continuously, and then you're just updating what frequency the streamer is going to update at.
Right. And we could use well, we can't use our own streamer because it's feeding bytecodes for spin 2, right? So we have to have another cog to do this job.
In a place of an inverter with the smart pins, is there a way for the smart pins to do the feedback?
Sure. Yeah, I mean, you have ADCs and all kinds of ways to measure crossings.
No, I mean, as far as the setup for a smart pin, is that cooked into the die, or is that just more code?
It'd just be more code. Yeah, you can configure it. I mean, right now I have right here. Let's see, where do I do it? Here I set up however many pins you specified to be DAC outputs, and then that's what this does right here. This sets the DAC mode, and then this turns on the outputs. So they're driving. The DACs are now driving, and then the setup for the pin is this value right here. And then these bits right here get written with the cog number because these are DAC channels. They go all over the chip and they repeat every 4 pins. So this guy at runtime actually it gets rewritten and becomes like this. It's cog 1. But I have it set itself up right here. It gets its ID and then it writes it into this nibble right here.
That is awesome. Thank you, Chip. Thank you.
I know it's not, it just gives you a taste of kind of how things work. I know it's not at all your whole project, but you can kind of see how you have to, in this case, we're using the streamer, we have to configure it. We configure the pins, turn them on, turn the streamer on, and then we just modify the frequency if that's all that's of interest to us.
Another thing to note is that the setup code could have written anything it wanted into the loop. It doesn't have to be a sine wave. It could be whatever wave shape you want, and it will repeat it cycling.
Right. Yeah, up here we used the rotate chordic thing to get sine and cosine. But yeah, that could have just been a ramp.
Or noise or any other wave shape you want.
Right.
So it's a wave sampler.
Could you copy that code into the chat?
Yeah, how do I do it? Can I?
It might just come in cleanly. Let's try it and find out.
Well, okay, if I just, let's see, where's the chat at?
Control A.
I'm dubious it'll show up correctly in chat.
Yeah, let's see, chat. Where did the chat go? Here we go, chat. Okay, so there. I don't know if that'll copy. Well, maybe it will actually. Maybe you can just paste it, go up to the.
Probably going to wrap all over the place.
Yeah, I think it's going to really mess it up. But
let's see. Okay, I just grabbed it. Nope, I got it. It works.
Okay, now we can share more. Sharing is caring.
Yeah. It looks crazy, but it works.
Did I miss something? I'm not seeing it in the chat.
Oh, wait, I sent it to Ken privately. Hold on.
Yeah.
I didn't realize I had this. Hold on here.
I'm like, it's fine. What's wrong with everybody?
Yeah, there you go. Now do you see it, Jeff?
Yes.
Can you copy?
It actually doesn't look that bad.
Well, it turned out right on mine. I think this can be the new object exchange.
There we go. Develop code live. Share it.
Serendipity in chat window is great.
Everybody's got to repaste their latest version at the start of the meeting.
Paste it into Word just fine.
Okay, are you seeing sine waves on pin 0 and pin 1?
On your scope trace,
Yeah.
I can't see the scope at all. Can anybody else see the scope?
Oh, no, I didn't use debug.
I can't.
You'd have to use
The scope is way too far down. You have to. We don't have that big monitor like you have.
Yeah. You know, it doesn't have any debug stuff in it. It's just a program. Now I'd have to, well, you know what? We could make this into a thing here. Let's see. Well, wait, how are we going to know what it is? It's just outputting to the DAX. I'd have to write
You have to read the pins, right? And then you won't have a good a perfect representation.
We'd almost, I would have to tweak this. We'd have to see the data is all going through these internal channels in the chip, and it's not really available for looking at. So we'd have to like run the analog output into another pin and then look at that, you know, using the ADC. Could be done.
Yeah. So you're just sampling it so you get like stair steps and stuff.
Right.
But the main point is, look at that, guys. I mean, he is building up a small table and then he is running a loop. The same as TV. I mean, chip, honestly, once you get that set up, it's freaking short code. Usually, with a lot of your examples. I mean, I don't know. I'm fighting with that language. But once done, it's freaking short.
Yeah, I have to go into granny gear when I make code like this, because I have to go look at the streamer config values, and there's all kinds of like, you know, wide bit fields that need to be set up to make it go. So I have to slow way down. But you know, ultimately we could have objects that just take care of that for people.
I was just going to say, this is what we need you working on, Chip, to write a bunch of nice little objects that wrap around these concepts and make it simple for the rest of us.
Hey, the whole time I was working on the chip, I was looking forward to the day I could do that. So I think I'm just about there. I don't think there's anything major I need to do with the debug. Oh, I made a log file so that you can, it's in the documentation. If you define a symbol called debug_log_size, it's default 0, but if you put like, you know, 1 million in there, it'll record the first 1,000,000 bytes of the debug stream. So some people, I know, John Titus wanted to be able to go back and look. And so you can save a debug or a log file of the debug now.
Chip, can I ask a question on that sine wave generator? What do you think the resolution is? If I were working on an ultrasound frequency of say 32 kilohertz, would you be able to resolve the difference between 32,000 and 32,001?
Sure. Yeah, I mean, you have 32 bits of adder, so we could figure it out. Let's see, if we have, if 8,000 hex is our limit, and well, we have to, how would we do this? It would be the higher the clock frequency of the chip, the more resolution you're going to have. But what you could basically do, let me get my calculator here. If we take, let's see, 65536 times 32,768, that's that big number. And we divide that by, let's say we're running at 300 megahertz right now. We basically have 0.14 hertz resolution.
At 300?
Yeah, at 300 megahertz.
That's very good.
And it's completely linear. You can take that and that's your resolution for any frequency.
Would that work into the megahertz range then? Like a couple of megahertz?
Oh yeah, here, I can modify my, let me make this thing, I'm gonna make my little program go from like how about 1 million to 5 million.
At some point with the higher frequencies, you're going to start having quantizing, and you're not going to be able to get as much precision.
Well, if it's pure TDS, it should be pretty accurate.
Oh yeah, it'll go. Okay, let's see now. Let me get my I gotta turn my scope way up.
I just mean like if you're going 90 megahertz, you're not going to be able to measure the difference between 90 megahertz and 90 megahertz plus 1, right? 90.00001. Like it's not going to work.
So you see that's
yeah.
So that's one. There's 1 megahertz, 2 megahertz, 3 megahertz, 4, 5. Wait. Oh no, I'm stepping by half a megahertz. So that's going from 1 to 5 megahertz. Now let's go from 10 to 50 megahertz. That'll be better. Let's see, 10 to...
But go from like 1 to 1.1.
Okay, well, I'll step... I'll step 100. I'll step by 100 kilohertz. Okay.
All
so
we see right now is your hand.
I know. I got to move it over here. Okay, now. Okay, I've got the. Oh my goodness. Let me get the trigger. Okay.
Chip, I'm going to send you a document camera. That'll really help you.
Okay. Can
you need to aim the camera up a little bit.
Now,
there you go.
Every second, it's getting a little smaller.
Yeah.
Those are 100 kilohertz steps, and so it's over 10 megahertz now. And you can see it's still full scale. Let's speed this thing up so that like 10 times a second, let's say even 100 times a second, we step it by 10 kilohertz. Okay, now I'm going to run this. Oh, it actually does attenuate, but that might be my scope because we're going to 50 megahertz. This is a 100 megahertz scope. So I know that attenuation is not happening on the pin. It's probably happening on the scope.
How do you overcome that?
Get a more expensive scope.
Okay.
Yeah.
Yeah.
And I've got the low impedance DAC mode. I've got the 100. Let me move it to 75 ohm mode. It'll be small. Maybe it won't shrink as much.
I've run into similar problems with logic analyzers. When you start going too fast, you start getting jitter and weird attenuation-like effects.
That's not your active probe scope.
You can see there's two. Let me just get it down to one sine wave. So it's going there. It's going from 10 to 50 megahertz. Yeah, if I had a faster scope, we could see it better.
But Skip, what's the highest frequency you're going to?
50 meg.
And your scope is 100 megahertz bandwidth.
Right.
That means it's down 3 dB at 100. So this is shrinking a lot more than you'd think for 10 megahertz.
Well, okay, look, yeah, I agree. You notice it's not shrinking as much as it was. I reduced the impedance. And see how it's not getting as small as it was? Okay, you want to see real trash? Let's put it in 600 ohm mode. See, let me get the. Okay, there's 600 ohm mode, right?
Yeah.
Now we'll put it in 75 ohm mode. That's 50 back to 10. So that made a big difference. If I go to 120 ohm mode, it actually shrinks. No, it's not that much. Why was it shrinking more before? Was there something about my setup, or that I had 2 channels going.
That's what
Oh, yeah, look at that. So my scope, I think it's multiplexing its ADC.
Oh,
See that? There's 1 channel, right? When
That's
I
probably-
turn the
it's-
other channel on,
It's probably only 100 megahertz for 1 channel, and it's divided for 2.
yeah.
yeah, it must be. It must be, because when I go just to 1 channel, it's quite a bit different.
All right. Thank you.
Let's make it go to
Chip.
100 meg. That's only 3 samples per.
Chip,
Wow.
is there any way you can show me on your code there where you're switching the ohms on the sine wave? Is that the feed
Oh,
mode
yeah,
setting?
it's, let's see. Okay, it's the .pm, the .p mode. You see how it says 10110?
Correct.
That is 123 ohm 3 volt. If you make that like 10111, that's 75 ohm 2 volt mode, which is a little stouter.
So it's
I
that
don't see much
MSB
shrinkage.
on that.
The MSB it's 10111. But the code you copied and pasted was 10110.
Correct.
Maybe aim the camera up a little bit, Chip.
Yeah, sorry, I'm leaning the other way. There you can see it now. So it's going to 100 megahertz before it goes back to 10. So see, it really starts attenuating, and we just don't have that many samples either. But I think it's the scope. I think if we had a faster scope, we'd see some harsh looking wave by the time we got to 100 megahertz, but it would be full scale. Because the pin, unloaded, the pin will transition within like 2.5 nanoseconds on the low impedance stack.
That's what I was trying to get at earlier when I was saying when you get up to the higher frequencies, you start not having as much precision in the wave shape.
Right.
Because
Now,
there's
on
not
average,
as many samples.
Right. It gets rough looking, but if you look at it on a spectrum analyzer, the center frequency is in exactly the right place. You just get a lot of side lobes because there's a lot of harmonic noise.
Right. Suddenly dead air.
Yeah.
Hey, Chip, since you were talking about debug stuff, I was playing with the MIDI debug, and I was getting stuck keys on the debug screen.
Oh, okay. That would be because you weren't getting the note off messages, probably. Could that be?
Right. Yeah. Well, this is why in MIDI, and this particular device doesn't send note off messages. It also does. I don't know, because the MIDI, your MIDI code is built into the debug, so I can't see it. But it is using what's called running status as well. Are you keeping aware of that? Because this particular keyboard, I think I have it here. You know, this dude. It's an older M Audio Oxygen. It only sends note ons, and it uses running status. So when you press a key, you get a full note on. You get the three bytes. When you release it, you only get 2 bytes. You get the note value, and you get a 0.
Yeah, running status is a
running status. So it's a
feature
note,
you need to support.
same note but 0.
Is that a
So-
feature that's called out at like the start of the protocol or something so we could detect it?
It's
No,
a standard feature of MIDI 1.
Most MIDI devices work that way. If you hit one key and hit it again and again and again, you're just going to get the second 2 bytes over and over and not the first byte because it's already issued it.
Yeah.
MIDI allows you to do that. You can send note on and then 20 keys with values all together without putting note ons between each one.
Yep.
similar for all the MIDI commands. So you need to handle running status. Running status is very common.
Okay, so in other words, yeah, because I'm looking for like, well, according to what the protocol said, it said you get a note on command, and that's going to be followed by a note number, right? Is that what happens? Let's see, note on.
Yeah. It's note on, the note number, and then the velocity.
Right. So you're saying what can happen is we can get note on and then a whole bunch of key numbers?
Then yes, you can get, as Roy was saying, you can get the pairs. You can get a new key number and a new velocity, and the running status, which is whatever with the last valid command, in this case was note on, gets applied to those bytes. So for this keyboard, when you press a key, you'll get a 3-byte message, the note on, and then the key, and then the velocity. When you release the key, you'll get the same key number and a velocity of 0. So that's running status. That's a note on of 0, which is the equivalent of a note off.
Yeah.
Well,
so basically, when you get MIDI commands, you go into a state for that command, and you should be able to receive notes and velocities until you get another command. So the way it works is it's the high bit. So if you get a new high bit, that means it's a new command. If the high bit's not on, it's another note or velocity.
Right.
So you need to make your state machine work that way, such that it remembers the last command for any new bytes it receives until it gets a new command.
And then to complicate things, you have to deal with real-time messages in the middle of the other stuff.
Right. But that's okay. I'm only looking for note on. Once a note on message occurs, you're always going to get a key and a velocity, right?
Yes, but
at least one.
Yes.
But what did you say, Roy?
I said you'll get at least one, but you may get many.